So we are asked to determine if the following series is either divergent or convergent. So how do we go about a problem like this? Well, first we're going to run what's called the divergence test. For any series that you don't easily know how to find the sum of, or if you just want to know if it's divergent or convergent, do the divergence test. And basically, I'll just write that dt. You're going to take the limit of the sequence. So we're going to say, what is the limit as n approaches infinity for 1 over n squared plus 1 quantity squared? Okay, if you get a value any more than 1, you know that you are going to get a divergent series, or sorry, any value other than 0, you're going to get a divergent series. If it is 0, you know it's just going to be some value. So let's see here. When we plug in infinity, we get 1 over infinity, that's 0, plus 1, that's 1 squared. This is 1. Therefore, this series is divergent. Alrighty? So we know that the series will be divergent by the divergence test, but there's another thing that we have to take into consideration here, is that the problem in this context wants us to solve this and prove that it's divergent with a comparison test or a limit comparison test. So although we did conclude that this series is divergent by the divergence test, let's still use a comparison test to really show that. So the first step is to identify, are all of your terms positive in your sequence? Well, start at your first one and keep going. As long as nothing's subtracted, it should never really have a problem with being 0 or anything less than that. So we notice 1 over 1 is 1 plus 1. So that's 2. The next term would keep going and keep going and keep going and keep going and keep going. So what we're going to do here is we're going to say, okay, we know by the divergence test that it's divergent. So let's prove it's divergent. We need to have a function that is greater than this function here that will give us another divergent function. Because if we know that, well, think about it. If I have my series here and it's going like this, right, and I want to prove it's divergent, if I have a series here that's also divergent, it's kind of like a squeeze theorem. It forces that series to also go to infinity, which would also be divergent. So think about it like this. What series is going to be less than this but be divergent? That's what the problem's asking you. So what I'll compare this to is the series infinity to n equals 1 for just 1 squared. Think about this. If all terms in the series is going to be 1, there's no n to plug in, so it's not multiplying factors, dividing factors, square factors, power factors. It's nothing like that. If you just notice here, it's just 1. So your first sequence would be 1. N equals 2 would be 1. 1,150. That's going to be 1. So every series just keeps adding 1. And we know that if you just keep adding for infinity, well, the area under the curve will be infinity. So if this is our function, we know it's going to be divergent. The limit as the series itself, the sums approach infinity, will be infinity for this. So it's going to be divergent. But let's compare 1 plus n squared plus 1. All right, what is the equality or inequality of this? Well, notice here we have a 1 squared, but we're also adding something. When we add something, we increase the value, granted it's not negative. So here we're adding something that's positive to what we have over here, so we know that this will be greater, which allows us to say, okay, this series is like this curve, and that series is like this curve on the bottom. So what happens is, well, as this thing's growing and growing and growing and growing and growing, well, this thing's growing and growing and growing and growing and growing. All right, so that's basically the solution and how I came to terms of it. Again, you could use the divergence test, but you can also show it saying, okay, well, if I know this series diverges and it's less than our initial series, well, then this series must also diverge. So that's 2 ways to show divergence. One way is just a simple test that you should be doing every single time you have a series you cannot easily find the sum of. But this test here is just an introductory kind of problem into the idea. In future videos you can check out, we'll be looking at more problems using the limit comparison test and also just the plain old comparison test. Hope you have a wonderful day. Thank you so much for watching. Please like, comment, and subscribe. Take care.